Okay, see, this is what's happening. It is in tissues. Can you see it clearly? Carbon dioxide in plasma, it enters into the RBC. It is given here. So, diffuses carbon dioxide, dissolves in water in the presence of carbon anhydrase. Okay, this is regarding the reaction taking place in tissues because carbon dioxide is produced in tissues. So, what is the reaction occurring in tissues? That reaction is concerned with carbon dioxide transportation, and oxygen is also released into tissues by Bohr effect. Okay, so and find the answer to the question that follows. The reaction represented occur in which region? Of course, it is in tissues. What the reaction for indicates? What is that reaction? Carbon dioxide is causing the split of oxyhemoglobin and oxygen is diffusing. You can see it. Oxygen is diffusing. What is that oxygen diffusion? That is Bohr effect. Okay. The reaction 1 to 6 thus represents the Bohr effect. Just now I told you. And what does the reaction for indicates? See, whenever there is diffusion of carbon dioxide, see, this carbon dioxide is entering in, diffusing with the water, diffusing into the RBC, dissolving the water, forming H2CO3, that is also split into hydrogen ion and H2CO3. That hydrogen ion is taken up by the hemoglobin. Why? Because hemoglobin, which was carrying oxygen, is split. Oxygen is going out and now hemoglobin is free. That hemoglobin will take that hydrogen and will form hemoglobinic acid, which is a very strong acid than oxyhemoglobin. That's why there is more acidity in tissues. Understand? That is why the pH is coming down. That is, in tissues, we are having hydrogen concentration high, pH is coming down, acidity we have studied. It is because of formation of hemoglobinic acid, HSB. And that will be affecting the hydrogen ion concentration. It is affecting the hydrogen ion concentrations, and to maintain the normalcy, the same level of same charges are diffusing in the opposite direction. So the carbon dioxide is diffusing out and equal number of bicarbonate ions. So this is what is called chloride shift or hamburger shift. Both are same. Chloride shift or hamburger shift are same. For every chloride ion, that is, bicarbonate ion that is going out, equal amount of chloride ion comes in. Okay. Here in tissues, bicarbonates are going out. Okay. And getting dissolved in the or combining with the sodium in the plasma, forming sodium bicarbonate. So only negative charge bicarbonate ions are going out means that will upset the pH within the RBC. So equal number of same charge, negative charge, chloride ions enter in. That is called chloride shift. So chloride ions are coming to the RBC, bicarbonate ions are going out of the RBC in tissues. In alveoli, it is just the reverse. As we reach the alveoli, what is the reaction that is occurring? Let us see. The sodium bicarbonate is splitting. Okay, this sodium bicarbonate splits. Sodium will be remaining and the bicarbonate ions enter. It will be combined with the hydrogen ion. Why hydrogen ion is released there. See, it was in the form of hemoglobinic acid. Hemoglobin was present in the form of hemoglobinic acid. Now, here you are having oxygen. That oxygen will be combined with the hemoglobin. Now, hydrogen ion is released. Okay. That hydrogen will be combined with the HCO3, forming H2CO3. This will be immediately splitting and will be forming carbon dioxide that escape out and water that is remaining in the RBC. This entire activity taking place in the alveoli is just reverse of what is happening in the tissues. Here bicarbonates are all getting in, negative charge ions getting in, equal number of chloride ions escape out. This chloride ion now combined with the sodium and will be forming sodium chloride again. This reciprocal exchange of, mutual exchange of chloride ions and bicarbonate ions between plasma and the RBC during carbon dioxide transportation is called Hamburger shift or chloride shift. Okay. In which condition the following reaction will occur? This is in tissues. Okay. In tissues we are having Bohr effect. What is the reason for Bohr effect? High partial pressure of carbon dioxide, high temperature, high hydrogen ion concentration. We can also add hydrogen ion concentration high. Under these conditions, this will occur. Clear? Hydrogen ion concentration high means pH low. Why it is pH low? Because hemoglobinic acid is converted into, see, in tissues, HHB is converted into less acidic. Okay, we are having hemoglobinic acid more acidic, HHB. In alveoli, we are having HHB converted to HbO2, which is also acidic but less acidic. That's why there is a change in pH. That change in pH, what is the real cause of that change in pH? It is hemoglobinic acid converted into HbO2. This is strong acid. This is mild acid. So there is a change in pH. That change in pH is responsible for the breaking of sodium bicarbonate. That's why sodium bicarbonate break and the carbon dioxide is released, resulting in the release of carbon dioxide in the alveoli. This is the Haldane effect. And this is what is happening in tissues. This is the Bohr effect. Clear? These are all occurring during transportation of carbon dioxide in the form of sodium carbonate. That part is not at all in our